Okay, good morning, everybody. So today we're going to finish up the lesson from yesterday. It was quite a monster. It's got a lot of skills in it. Unfortunately, there's one more that we didn't get to talk to about, and it's about something called a quadratic form. So I'm going to introduce that, and we'll practice a few problems with that. And then the rest of the hour will be work time, and you're going to need it because this stuff is kind of a pain in the butt. All right, our work today is solving some equations. So whenever you're trying to solve any polynomial, your goal is to set equal to 0, try to factor it with any techniques you got, and then you can look at when the factors themselves are actually equal to 0. So looking at number 1 right off the bat, you got a cubed minus 9a squared plus 14a. First thing you should scan for is, do they have something in common? And they all have an a, don't they? So we're going to factor an a out. Take out what you can. So taking out an a, then all of them have one less a, so it'd be an a squared minus a 9a plus a 14. So that's kind of factored. That's better. I mean, every time you do a little bit of factoring, the thing you're working on goes down a degree. This is a third degree. Now I'm working on factoring the second degree. So let's see, what techniques do we have to factor this? Well, probably just the normal stuff, actually, if it does factor. Can you think of two numbers that multiply to be positive 14, the last one, and add to be the middle one of negative 9? Can anybody think of a combination of numbers that multiply to be positive 14 and add to be negative 9? Negative 7 and negative 2 would work, absolutely. So that is all factored down. That's great. My goal for you eventually is if I give you a third degree problem, you should factor down into 1, 2, 3 different factors. If I give you a fifth degree problem, you should be able to do some work and get down to 1, 2, 3, 4, 5 factors. Once you get them down to all the factors, you just look at them individually when they're equal to 0, set them equal to 0. So this one, when you set equal to 0, it just flat out says that a is 0. You're done with that one. The other one, if you set equal to 0, if you set up an equation a minus 7 equals 0 and solve it, that means a is positive 7. And the other one, if you set up an equation a minus 2 is 0 and solve it, you get a equals positive 2. So you got 3 answers for that. And that's also the goal. If you have a third degree equation, there are 3 answers somewhere, somehow. And that's it. So that wasn't so bad. Number 2, let's do that thing. So it says you got an x cubed. Now, right off the bat, when you see a cubed thing, especially when you only got 2 of them, you should think maybe it's a sum of 2 cubes. And let's see if it is. Well, obviously, x cubed is something cubed. It's x cubed. And you don't have to write that parenthesis if you don't want to on that. I'm just doing that to show you structurally, okay, this is the thing that's cubed. But there's also some other thing cubed that does equal 216. 6, yeah, 6 cubed. If you look at your little table over here, it's 216. Great. So we found 2 things that do cube and add to be 0. So we're going to use our little equation here to do the factoring for us. A cubed plus b cubed is given by this expression right here. In our situation, a would have the role of x, b would have the role of 6. So type it in, it's going to factor into x plus 6 times this stuff, which is x squared, minus their product. So one was x and one was 6, so minus 6 times x. And then plus whatever that number b squared is, b was 6, and 6 squared is 36. Okay, great. So let's see what we got here. Can we factor the next one? Let's see if we can. Can anybody think of 2 numbers that multiply to be 36 and add to be negative 6? I can't either. So what do you do with a quadratic when you can't factor it? Go to Quadratic Formula. So this one's obvious, though. What's the answer from this one? X must be negative 6. That makes that 0. So there's one answer. The other 2 are buried inside the second degree, which I can't just figure out with looking at it. So I'm going to go to Quadratic Formula and figure out what that makes that 0. So here we go. Quadratic Formula, x equals negative b. B was negative 6. So negative b would be positive 6. Plus or minus the square root of the discriminant, which is b squared minus 4ac. Well, b squared would be 36 minus 4ac. In this quadratic, a is 1, c is 36, and that's all over 2a, and a was 1, so 2 times 1 is 2. That's a big number in the discriminant. You might want to get your calculator out and figure out what that is. 36 minus 4 times 36 Negative 108. I agree with that in my mind. Now, guys, do you remember what you do when you have a square root of a negative? You make an I. That's right. So these are going to have answers. They're just not going to be real, which is weird. And I guarantee you, a third degree will always have 3 answers. They might not be real, but there are going to be 3 of them. In fact, you can see there's 2 buried in here, right? 6 plus this and 6 minus this. And it's pretty good to go, unless we could maybe clean up that root any. I don't know. Let's see if we remember how to clean up roots. It's a square root. So to clean up a square root, you're looking for perfect squares that might go into 108. And I guarantee you 36 does. So could somebody figure out how many times? 3. Okay. So you might remember the old skills. We could take a square root and break it into 2 parts. 36 times 3 is still 108. So it's still the square root of 108, just written as the square root of 36 and square root of 3. And the whole reason you're doing that to clean up square roots is because the square root of 36 is pretty. It's 6. We still got this gross root 3, and that's I stuff, but that's okay. And that was worth doing because actually now we can distribute the division. Everything on top here can be divided by 2. So if you go term by term on top, 6 divided by 2 would be 3, right? And then this other term over here, well, again, you have a 6 divided by 2, which is, again, 3, right? But you also have this root 3i thing. So it's going to be plus or minus 3 from the 6 divided by 2. And then you still have that root 3 in the I. And that's as simple as that one's going to get. So there's 3 answers. Negative 6 from the easy one. And the gross one, we had to go to quadratic formula, but we did get out 2 other answers. So that's a grand total of 3. And that's what you should expect from a third degree problem. All right. See how we're kind of using all those skills from before? They're all coming back and playing a role. It's kind of interesting. All right, last one today, number 3. Now, this one is something we did not talk about yesterday. This is the last thing I want to teach you, and I'm going to teach you first thing as soon as we get done with this, and then we'll kind of break off and do what you need to do. This doesn't match any of the things we have. It's not a cube. I can't do grouping because grouping requires an even number of things, and I see 3 things. That ain't going to work. It ain't a difference of cubes or anything, so I'm kind of out of options. But you can write this in something that is called a quadratic form. It's kind of like a quadratic. You can write this as something squared plus 8 times something plus 15. If I put an x here, x squared plus 8x plus 15, you'd say that's a quadratic, right? It's a squared thing, right? Well, I can't write x's here, but there is something squared that is x to the 4th. It's x squared. X squared squared is x to the 4th. And right here, the same thing, x squared to the 1st. What do you do with your powers? When you have power to power, you just multiply, right? 2 times 1 is still 2. So this is something squared and something raised to the 1st power. So we can do a quadratic formula thing or a factoring thing on this, just like any other quadratic. We just won't be writing x's. Guess what we'll be writing? We'll be writing x squares. So I want you to just forget all the busyness for a second. I want you to look at the numbers, just like old factoring. Can you think of 2 numbers that multiply to be 15 and add to be 8? 3 and 5. Okay, so like normal, there'll be a plus 3 and a plus 5. It's still a quadratic. You're doing the same thing you do with the quadratic. The difference is what? Well, yeah, it's x squared stuff in the factoring. So when you write your factors, it's not going to be x's. It's going to be x squared. And that's a weird little concept. People usually struggle with that one a little bit. When you show them like something like this, they usually can't see that it's in the structure of something squared plus 8 times something or whatever. But we got to factor down some, which is nice. Now, these are not easy to factor from here. So like anything, the whole point of this is if you're trying to figure out the answers to this, you're trying to get that equal to 0. See when the factors themselves are equal to 0. So this factor, let's set equal to 0. Pretty easy to solve this, actually. If you move the 3 to the other side, it's a negative 3 then, right? And how do you want to do a square? With a, don't forget your what? Plus or minus. Okay, so x is plus or minus the square root of this thing. Now it's negative, and the square root of a negative is i's. So this thing's factors, this thing's answers that make it is equal to 0, are positive square root of 3i and negative square root of 3i. Note there's 2 of them. because this little chunk I'm working on is a second degree. And this one's a second degree, so it will also give me 2 answers, but by the exact same logic. Whatever your factor is, set it equal to 0, attempt to solve the thing. It'll be the exact same logic. It's just going to be a 5 instead of a 3. So you move the -5 over into -5. Take a square root. Don't forget your plus or minus. Square root of a negative is an I thing. And there's 4 answers. Positive square root of 3i, negative square root of 3i, positive square root of 5i, and negative square root of 5i. 4 answers for a 4th degree equation, and that's exactly how life should go. So there's your 2 answers. Now, if you graphed this thing, by the way, would you see it cross the axis anywhere? The answer is no, because these are imaginary, right? Imaginaries you don't see. So this might be the type of problem where I say, go find the zeros of this thing, and you go graph it, and you have nothing, it doesn't cross ever. And you might say, well, it has no zeros. It does have zeros. They're just not real. They're all imaginary, complex, weird stuff. But there are 4 of them because it's a 4th degree. So that's the overarching theme I really want you to understand about polynomials. Whatever degree problem I give you, that's how many answers you should have. LGs. All right, we are going to be working on factoring more polynomials. And this one thing right here, this quadratic form, is the last little trick we have. I don't care how high you go. You go to pre-calc, you go to calc or whatever, and you need to factor something. I don't care what class you're in. It's basically these kind of tricks are what you have in your tool belt. Hey, maybe it's a sum of squares. Maybe it's a sum of cubes. Maybe it's a difference of cubes. Maybe I can do grouping. Maybe it's a quadratic form, which we're going to study today. Those are all your little cute things. There is an overall strategy to attack one of these problems that we will be talking about in subsequent lessons. But as far as quick tricks to get things accomplished, this is it. This is all I have in my brain. This is all most people have in their brain as far as helping you solve things. All right, so you do have your homework 5.2. It's due on Tuesday. Let's finish up the lesson real quick. So go back to your notes, and we're going to tack on this little part about quadratic forms and then call it a day. Okay, so here's the last thing. Something's called a quadratic form. I'll kind of try to put it on the board for you here. Here's a definition for you. Quadratic form. And this is a polynomial that can somehow be written in the form a times something squared. I'm going to use u. I'm not going to use x. So you could use x. It doesn't matter. But I'm going to use u. AU squared plus BU plus C. So if you can get something to look like that, who knows what u was? In the warm-up, u was x squared. In the warm-up, I found out, oh, x squared is something, and that was x squared right there. So if you can write it like this, then life is good, and that's kind of good. Then you can, this isn't really the definition, I'm just giving you the strategy. Then you can solve it like a normal quadratic. And for any quadratic, we got completing the squares, we got factoring, we got quadratic formula, of course. Solve like a normal quadratic. That's basically all there is to it. How can you spot if something is a quadratic form? Let me give you a little hint here. Just expect what to see in the thing. There will be 3 terms all the time. There'll always be 3 terms, 1, 2, 3 things. And the exponent of the first term is twice the exponent of the middle term. Twice the exponent of the middle term. If you look back to our warm-up, that's exactly what happened in our warm-up. We had an x to the 4th plus an 8x squared plus a 15. That was our example. And you notice It's got 3 terms, right? And this exponent is exactly twice of that one. So if you see that pop out at you, that means it's a quadratic form, and you're going to try to factor it just like a quadratic. So let's look at some examples of this. There's none on the board. I'll just make some up on the fly. We'll do 2 or 3 and then call it a day. All right, let's say I gave you this. X to the 4th minus 7x squared plus 12. So somebody throws this at you and it looks crazy. It's not a quadratic, it's a 4th degree, but it has the structure of a quadratic. Could you write the first thing as something squared? That's what a quadratic is. A quadratic starts off with something squared minus 7 times a something. X squared, agreed, just like the warm-up, right? So if I think of this as x squared and I think of this as just an x squared, then it looks like a quadratic. Something squared minus 7 times something plus 12 equals 0. In fact, really quickly, I'm just going to, you don't have to do this, but if it helps you to see what's going on, you could make a little substitution. Maybe make the thing that's squared called u. And then if I replace all the x squares with u's, then this is u squared minus 7u plus 12. And if you do that, it might be a little more obvious to you what you're working with. Looking at this looks a little scary, probably to you, right? This might look a little bit cleaner. So how would you factor this thing? Can you think of 2 numbers that multiply by 12 and add to be -7? -4 and -3, I agree. So you could factor this into u minus 3 and u minus 4. Now you don't have to use the letter u. I'm just using the letter u to show you you're doing the same thing you always do. Letter u really just stands for x squared, right? So really this factors down into x squared minus 3 and x squared minus 4. And you don't have to do that intermediate step. If you don't want to do any of this u intermediate things, that's totally okay with me. But you got to see then that structurally this thing is x squared is the thing that's squared, x squared is the thing next to in the middle. So when I factor it, I'm not going to use x's, I'm going to use x squares. And then you proceed to solve from there. I'm not going to bore you with the quadratic and you set equals 0, plus or minus, all that crap. Let's try another one. How about this? And they're not all x to the 4th. It could be different. How about this one? X to the 6th. Ooh. Plus 2x to the 3rd plus 1 equals 0. Does it fit the format of a quadratic form? Is there 3 things? Yes, there are. Is the exponent of the leading one twice the middle one? Yes, it is. Twice of 3 is 6. So this is a quadratic form. So you want to think of it as something squared plus 2 times something plus 1. If you look at my parentheses and write the word x, you know exactly what to do. You could factor it and all this other stuff. But we're not going to write x. Where are we going to put here, guys? You got any clues? What would go here so when I square it, I get x to the 6th? X to the 3rd, yeah. So this time I'm going to be factoring without x squares, but x to the 3rd. So you see it's the same structure, though. Something squared plus 2 times something plus 1. So just factor it like normal. Can you think of 2 numbers that multiply to be 1 and add to be 2? 1 and 1. So they're both going to be plus 1s. But the thing that goes in here isn't going to be x or x squared. It's going to be what? X cubed, exactly. So you put an x cubed, put an x cubed. Now there'd be more work to do. I won't do it because that's not the point of what I'm talking about right now. But this is a sum of squares, sum of cubes. 1 cubed is 1, right? X cubed is x cubed. So this is a sum of cubes, and you could go to these formulas and keep working from there. But this just gets you started. Get you started on the factoring. Now I won't make you do it right now. All right, more. Can't do enough quadratic forms. It's a good technique. It's a good technique. Comes up sometimes. X to the 102nd power. Why not? Minus, I don't know, 6x to the 51st power plus 8 equals 0. Now, there's no way in heck I'd ever ask you to solve this because how many answers does it have? It has 102 answers. It's a 102nd degree problem. That would take you like weeks. I don't think you could even do it. Nonetheless, we could get it started. because there's three things, and this exponent is twice of that one, so it is a quadratic form, so we can, in fact, factor it. I just start off with the numbers. Can you think of two numbers that multiply to be positive 8 and add to be negative 6? I'm thinking negative 4 and negative 2. That works, right? They multiply to be positive 8. They add to be negative 6. Great. But what goes here? Well, I kind of skipped a step, but let's try to rewrite this thing as something squared and 6 times something and 8. And guess what the something is? Anybody know what the something is? You can probably spot it. X to the 51st, right? So usually it's just the middle thing, right? Every single time. Whatever the middle thing is, that's what kind of goes down here. So when I factor this thing, it's going to factor into x to the 51st minus 4 and x to the 51st minus 2. And God knows what you would do with those things, but you could break them down farther and try to at least. I'd rather work with a 51st degree than a 102nd degree. So that's the point. The point of factoring is to just whittle it down to smaller and smaller exponents, and then it should be okay. All right, one more. Let's do one more. X to the 16th plus 9 x to the, what exponent do I have to write next? Anybody know? 8. I'm going to write an 8. Yep. 9x to the 8. And then how about a plus 20 or something like that? We'll make it real simple. All right. Probably don't want to get ahead of myself. I don't want to skip steps. I tell you not to skip steps. I shouldn't model skipping steps. Let's just write this as something squared plus 9 times something plus 20. What's the something going to be? You are correct. So we're going to write this as a quadratic form. It's kind of like a quadratic. The only difference is a quadratic using x to the 8s instead of x's. So we're going to factor it like we would normally. We're just not going to use x's. We're going to use x to the 8th. So hopefully there's x to the 8th that we can put in there. And now I got to think, is there two numbers that multiply to be 20 and add to be 9? And yes, there are. 4 and 5. And then if this is actually a problem on a test or something like that, you have to keep trying to factor this down and stuff like that. But I would never give you a 16th degree or something like that. On the test, probably the highest degree I'd give you is like a 5th degree or something like that. So that's it. That's quadratic forms. It's a really handy thing, okay? Like some of these things come up once in a while. These come up once in a while. Grouping comes up a while. Quadratic forms come up a lot. So that's a good skill to get under your belt. Questions at all? Okay, that actually concludes the lesson then from yesterday. Section 5.2. You have all the rest of the hour to work on your homework regarding this, so get a jump on that. Again, I strongly kind of encourage you to do this on paper. It's very picky online about where you put boxes and things like that. And I'm not helping you with that nonsense. So if I was you, especially because it's kind of complicated, might want to get some partial credit if I jack it up. I would do this one on paper, but you do you. I ain't your dad.